Next we are going to see normal distribution as a limiting form of binomial distribution. Normal distribution is a limiting form of binomial distribution with the following conditions, right? So if the conditions are satisfied, then normal distribution tends to binomial distribution, and that is binomial tends to normal distribution, right? N, the number of trials infinitely large n, right? First condition, that is n tends to infinite. Neither p nor q is very small, so both should be more, not small, that is should be high, right? We know that binomial distribution with parameter n and p, mean expected value of x is equal to mu, that is np, and variance, that is sigma square, that is npq, right? We know binomial distribution. Under the above two conditions, the distribution of standard variate z is equal to x minus mu by sigma. Substituting the value of mu and sigma, x minus np by root npq, right? So that is equation number 1. Now mgf, moment generating function of z, is given by mz of t, which is equal to expected value of e power tz. That is the definition, right? So substituting z value, right? Expected value of e power t into x minus np by root npq, right? So which is equal to expected value of, we are splitting into 2, so just first term power, first power tx by root npq, right? E power tx by root npq, then t into np minus t np, so second power is e power minus t np by root npq. So we are splitting that. So expected value of first one, because this expected value is only applicable for x, remaining all constant, so e power minus t np root npq is a constant with respect to that expectation. Take it outside from the expectation, so e power minus t np by root npq into expected value of tx, e power tx divided by root npq. So e power minus t np by root npq into expected value of t e power t by root npq into x. So e power minus t np by root npq, that is nothing but moment generating function, right? mx t root npq, because instead of t you are having t by root npq, I mean moment generating function definition, right? So moment generating function of x t is e expected value of e power tx. So instead of t you are having t by root npq, that is mx of t by root npq, right? That is equation number 2. We know that moment generating function of a binomial distribution, mx of t is equal to q plus p e power t whole power n, that is equation number 3. Using 3 into mz of t is equal to e power minus t npq by root npq into, we are substituting the moment generating function, right? Applying the moment generating function of binomial distribution, q plus p e power t divided by root npq. Instead of t you are having here t by root npq in the equation 2, right? Whole power n. Taking log on both sides, so log mz of t is equal to log e power minus t npq by root npq into q plus p e power t by root npq whole power n. So that is equal to log, we know log a b, which is equal to log a plus log b. So here there are two terms, e power minus t npq, np by root npq one term, and into q plus p e power t by root npq whole power n second term, ab, right? Log ab, so log a, log e power minus t npq by root npq plus log second term q plus p e power t by root npq whole power n, right? So that is equal to we know log e power x is x log e, right? So power will come to the front, log a power b is equal to b log a, right? We are using that formula, minus t npq divided by root npq log e plus, similarly for the second term, n log q plus p e power t by root npq, right? So that is equal to minus t np by root npq, log e value is 1, so plus n log q plus p into, we are doing the expansion of e power x. E power x is equal to 1 plus x by factorial 1 plus x square by factorial 2, etc., etc. Instead of x, you are having t divided by root n p q. So n log q plus p into 1 plus x by 1 factorial, t root n p q by 1 factorial plus t by root n p q whole square, x square by 2 factorial plus etc., etc. Right? So that is equal to minus t n p divided by root n p q plus n log q plus p plus pt. So we are removing, simplifying, right? Pt by root n p q plus pt square by 2 factorial n p q plus etc., etc. Right? So that is equal, because q is equal to 1 minus p, we are using that idea, right? That is why q is equal to 1 minus p plus p pt by root n p q plus pt square by 2 factorial n p q plus etc., etc. minus t n p by root n p q plus n log 1 plus, so p minus p get cancelled, 1 plus pt by root n p q plus pt square by 2 factorial n p q plus etc., etc. So that is equal to minus t n p by root n p q plus n log 1 plus x formula, right? X minus 1 by 2 x square plus 1 by 3 x cubed, etc., etc., right? So instead of x, you are having a big term, a series, right? pt by n root n p q plus pt square by 2 factorial n p q plus etc., etc. That is x, 1 plus x. So n into x, pt by root n p q plus pt square by 2 factorial n p q plus etc., etc. minus 1 by 2 x square, pt by root n p q plus pt square by 2 factorial n p q plus etc., etc. whole square plus etc., etc. right? So minus t n p q by root n p q plus multiplying with n pt by root n p q plus n pt square by 2 n p q plus etc., etc. Then multiplying with the other term, minus 1 by 2 into n, right? Minus 1 by 2 n into, so we are squaring, right? A plus b plus c etc., etc. the whole square, right? A square, right? So we are taking the square term first, right? Minus 1 by 2 n p square t square by n p q minus 1 by 2, right? Next term square, n p square, because a square plus b square plus c square plus etc., etc. then 2ab 2bc 2, like that it will go. So we are taking just two terms, right? First two terms, minus 1 by 2 n p square t power 4 into 4 n square p square q square, because this minus is because we are having minus in the front side, minus 1 by 2, that is why minus etc., etc. that is equal to n p t square by 2 n p q. So that first two term get cancelled, right? So first term, that is in the previous step, first to minus plus, minus t n p by root n p q plus t n p by root n p q get cancelled. So n p t square by 2 n p q minus 1 by 2 n p square t square or n p q plus order of 1 by n power. So power of n square n cube terms, n power 4 term, it will come like that. So that is why we are simply writing, we are considering only the linear power of n, that is n power 1 terms, right? So that is equal to np square by 2 npq, right? We are taking that is common, so remaining term 1 minus p plus order of 1 by n power n. So np t square by 2 npq, 1 minus p is q, so q in numerator and denominator get cancelled, plus on order of 1 by n power n terms. So log mz of t is equal to t square by 2 plus order of 1 by n power n. That is equation number 4. We know that as n tends to infinite, 1 by n power n tends to 0, right? From 4, as n tends to infinite, log mz t, which is equal to t square by 2. mz of t is equal to, so we are taking reverse side, right? E power t square by 2. When you are taking log x, log a is equal to b means a is equal to e power b, right? So same idea. So e power t square by 2 as n tends to infinite. As n tends to infinite, the moment generating function of z is identical with the standard normal distribution, e power t square by 2, right? As n tends to infinite, z is a normal distribution with mean 0 and variance 1, that is standard normal distribution. Hence the normal distribution is a limiting form of binomial distribution. Thanks.